And welcome back, Mindsetters. Hope you have a nice little break. In fact, no, not even a break. You see, I've been doing these shows for too long now. Now every show just blends into the next one. But anyway, welcome, Mindsetters, to this session of Grade 12 Learn Extra. I hope you guys got your pens and pads out and you're ready to make notes. I have Phil here with me, who's back with me, who was doing the Grade 10 show earlier. And now we're ready to do this Grade 12 session. So I hope you guys have gotten your pens and pads ready and you're going to make some notes. But on that note, Phil, what are we doing today?
Okay, well, today's a little bit of an interactive lesson. We're going to be doing some revision of last year's physics paper. This is going to be one of 4 revision sessions, and today we're going to be taking apart the November 2011 paper.
All right.
Okay.
So, on that note, while you make your way across the board, I'm going to tell the Mindsetters, you know the drill. Make sure that you get on the page. Make sure that you start posting your questions. I know you guys have got major exams coming up. No pressure, though. That's why we're here. You guys need to post your questions if you're lost and if you need help. I will be also making sure that I post some diagrams for you guys. So, on that note, I'm going to hand over straight to Phil, who's going to continue the show. Phil, take it away.
Thank you so much, Ty. Okay, well, grade 12s, as I said, we're going to be taking a very, very close look at the November 2001 paper 1. So we're going to start off with a little bit of physics. What I've decided to do is I'm going to be taking you through the multiple choice question 3, question 4, question 5 today, and we're going to leave the next piece of physics until 2 weeks' time. So we're going to take apart this physics paper. So what I've asked Ty to do is actually start posting up these questions. I've tried to make them the same size that you can read them on your cell phone or you can read them on your computer, however you're following us, and you can actually answer these with us. And I'm going to be reasoning my way through all of these questions piece by piece. So I want you to follow through with us, take down some of our answers. This paper is available on our website. It is available on the Thutong website, and we're going to be posting it in tiny bits and pieces. So you can actually follow through with us today, and I want you to try these questions before I even get to the right answer. So I want to make sure that you guys are doing this with me. You're writing down the correct answer, and who knows, maybe you learned something new and there's something that you didn't know before or something that you didn't really understand. Okay, so I'm going to be walking you through some multiple choice questions in questions 2, and I'm going to be asking Ty from now on in to start posting these bits and pieces. So question 2.1, question 2.2, question 2.3. So he's going to be posting those up on the Facebook page. So watch out for those. Okay, now I just wanted to give you a little bit of advice before we climbed into these multiple choice questions. Gives myself a little bit of time to get into this and tie some time to post up some of those questions onto the page. But I need you to make sure that you're approaching multiple choice in the correct way. Because for a while there was no multiple choice in the final paper, but in the last few years it's come back in a big way. And it's in there, it's 2 marks apiece, and there are 10 of these questions. Now, that's a big chunk of your final paper. And I want to make sure that you're going about this exactly the right way. Okay, now all of them start out with some sort of statement or diagram, and there's 4 options. Now some people say, okay, well this is multiple guess. That is not the way that I want you to approach this. Now, there's a couple of ways to approach these, and the way which I prefer to do this is without looking at the answers first. That is the ideal way. Now, all of these have got answers which you're just looking to find. Now, I'm going to show you what happens if you don't find one of those answers, if you're really, really stuck, and it does turn into a sort of like, well, I think it's that one, but it might be that one. Okay, so what we're going to do is we're going to take a look at the first one. I'm going to show you what my approach means. Okay, so what I'm going to do is I'm going to suggest that you don't even look at the options before you've thought of an answer. So what we're going to do is we're going to take a look at the important pieces of information, and let's see how this works. Okay, so question 2.1. I'm in there and I'm busy with my physics final and the pressure is on. And just to remind you guys, your finals are coming up, so you better pay some attention. Okay, so question 2, November 2011, these guys are stressing. How do we get rid of that stress? How do we go through multiple choice without it being painful? Okay, well, the first way to make sure that they can't trip me up with some false answers is to make my mind up before I read any of these options. Okay, so let's start to deal with some of these things. Okay, the first one is a definition. So let's deal with some of the numbers. Okay, so number 2.1. All right, so now first of all it says impulse is equal to the. Okay, now I want you to start thinking about what is impulse? What is impulse? Don't start taking a look through the options. They're going to misguide you. And that's what those other options are there to do. Now, those other options are there to sound as if they're right. Okay, and the problem is that they all kind of do sound right. They all kind of sound sciencey. You've got a little bit of physics terminology. That's not the way to do this. Don't go looking for the answer. Know the answer, and then try and match it up with A, B, C, or D. So let's do this. Impulse is equal to the. Well, I remember that impulse was kind of something to do with momentum. And if you remember that impulse is the change in momentum, that gives me a starting point for taking a look through this. Okay, well, let's take a look. I would sit there with a pencil, and we can cross off the ones which we know are incorrect, and we can leave ourselves with ones which we think are. Okay, well, impulse is equal to the initial momentum. I'm not entirely sure the word momentum is in there. It's a maybe. The final momentum of a body. Okay, well, that doesn't sound quite right either. Okay, C, the change in momentum of a body. Okay, well, this is starting to look a little bit more, sort of sane. Okay, I've got an idea of what's going on here. It's something to do with momentum. Then the rate of change in momentum of a body. Okay, well, this is all starting to look a little bit familiar. But what I'm going to do is I'm going to make my life a little bit easier. Okay, so my first approach didn't work. I thought that impulse was something to do with change in momentum, and everything had momentum in. So what do I do now? What I'm going to start doing is I'm going to start crossing out things which I'm fairly sure that I know they're incorrect. Well, I know that impulse is not an amount of momentum. My brain said that it was a change in momentum. And the ones which I thought would be correct would be C and D. So let's get rid of option A. All right, so it's not the initial momentum of a body, because that is just the initial momentum of a body, nor is it the final momentum of a body. So it's not option A, it's not option B. Now we're left with a 50-50 choice, and that really improves my chances. Okay, so now let's start to take a look at some of these other bits and pieces. The change in momentum of a body. Well, that was my first option, so I think I've got option C. But now let's just investigate option D and check if that might be right. The rate of change in momentum of a body. Okay, well, if I'm not entirely sure, what I can actually do is grab my formula sheet, and I can say, okay, well, rate of change in momentum. Well, let's actually make a sum which says the rate of change of momentum. Delta P, which is change in momentum, and to make it into a rate, I'll say delta T. But hang on a second, I can find this on my formula sheet. My formula sheet tells me that that is a formula for finding the resultant or net force of something. So D is incorrect. Okay, now that should show me something. I should have gone with my gut feel initially. Change in momentum in an object was right all along. But what we did was we very cleverly eliminated all the other options. Okay, I knew that it wasn't the initial or the final momentum of a body because those were exactly that. I thought it had something to do with the change in momentum, but they threw in option D. Option D was there to confuse me. So what I did was I changed it into something which I knew, and I looked on my formula sheet, and I saw that the rate of change in momentum of a body was actually the F res, or the F resultant. My initial guess was correct. So option C was my first answer. I know with confidence that that's the right answer now. So what I'm going to do now is I'm going to move onwards to my next question. Now this one's a real challenge. Okay, so question 2.2, and I hope you guys are following at home. Okay, now let's see what's going on inside this question. I'm going to highlight some of the important pieces of information. It says, an object is pulled along a straight horizontal road. Okay, that's pretty important. So straight horizontal road, there it is. I am being told that it's being pulled horizontally. To the right, okay? So that's important as well, because we now know where it's going without being lifted. So it's not being raised off the ground. The force diagram shows all the forces acting on the object. Let me just highlight what they are because it's kind of difficult to see and they're nice and small. All right, so let's take a look. What have we got? We've got F, which is the applied force. We've got N, which is the normal force. That's the floor pushing back up on the block. And we've got W, which is standing for the weight of the object. And we've got small f, which is the friction of the object. Now, it says the force diagram shows all these forces. Great. Now it says which one of the above forces does positive work. Oh, well, now I've got a little bit of a problem. Okay, well, first of all, before I even get tangled up by the idea of positive work, let's figure out what work is itself. Okay? So grade 12s, you know all about hard work. You're busy hard working at the moment. So what we're going to do is we're going to take work and try and figure out how to calculate that. Well, work needs a force. More than that, right? If I take a force and I multiply it by some sort of displacement, and I've got cos of the angle in between them. Okay, the only way that I can get a positive version of this to come out, now that's the formula for work. The only way that I can make this positive is if over here I've got displacement and force in the same direction. Now that should be a little bit of a clue. Well, now using just this information, I can increase my chances of winning. Here's how. I know that displacement and force must be in the same plane of motion. That's a little bit of a hint. You cannot do work if there's no displacement and force acting in the same direction. So we were told that it was horizontal. Okay? So that means that vertical forces cannot do work. So let's get rid of them. N and W. So the normal force and weight are not going to do any work here. So that's option A and option B right out of the window. Okay, now what I've got to do is I've got to start to think, well, how on earth am I going to get this to be positive work? Well, now here's your definition for positive work, and you might want to write this down. Positive work is when the force and the displacement are in the same direction. Okay, so let me just repeat that. Force and displacement are in the same direction. That means that the force is helping the displacement happen. Okay, well, remember earlier on it told me that I was moving odds to the right. There we go. There was my information. Only one of these forces is actually helping me do that. And here it is. There it is, my applied force, and that is option D. I know that for sure, but there's always some doubt. What about frictional force? Friction is also horizontal. How do I make sure that that's not the one for me? Well, I know that if displacement is to the right and friction is to the left, I can actually work with this equation. If I really want to make sure, if you put in cos of 180, let me show you where the 180 comes from. If I've got my displacement in one direction, so there's my displacement, but the force is in the other, the angle between my displacement, so there's my displacement, delta x, my delta x and my applied F, that is 180. Go ahead and put in cos 180. What you will find is a negative value. That means that I've done negative work. That's proven that I've chosen the right one. So now I've made doubly sure that friction is not the one for me, because friction does negative work on objects. Right. In general, friction is always going to do negative objects. It always takes energy away from an object. Okay, so we're doing pretty well. Usually you guys wouldn't stop and consider this so carefully, but sometimes you get a little bit of time at the end of the exam, and I want to make sure that everything is correct, so that none of the other options could actually be right. Okay, moving onwards. So we're doing fairly well. We're fairly sure of our first few answers. Okay, now comes along a really weird graph. Okay, now I'm pretty sure that the metrics kind of freaked out a little bit when they saw this graph at first, but it's actually easier than we think. Slow down, breathe, let's start reading together. So a ball is released from rest. Okay. So I know that initially this object is being released from rest, from a certain height above the floor. Okay? And then it bounces off the floor a number of times. The position time graph below represents the motion of the bouncing ball from the instant it is released from rest. Okay. Now, what we've got to do is we've got to identify where all this information fits onto my graph. Okay? So what I'm going to do is I'm going to highlight what happened in the beginning. In the beginning, we were told that there was rest. Okay? So this is when the ball is dropped. Now, the reason that this position time graph looks so strange is because it's upside down. So what starts to happen is as the ball falls, I can see that the ball is falling over there. What happens at point A? There's a sudden change in velocity from a positive slope to a negative slope. And that sounds a lot to me like this ball was bouncing. So what happened was it bounced at A. Okay, I can see that along the same displacement or the same position, I see another similar point. So I know that A and C must be where the ball bounced. Okay, So now I know that A and C are actually representing the floor. Now that's what's kind of weird about this graph. A and C are points which represent where the ball is bouncing. How did I know that? Well, what I needed to know was that I started off from there, position 0. What happened? I went away from position 0, and then I bounced and came back to position 0, but not quite. I came nearly as high. Okay, so position B and D are the places which are far away from the ground. Okay, let's just go through that again. That was really confusing. So what I'm going to do, I started off from rest. This is where I begin. What you've got to do is realize that they actually tell us some information over there. I released it from rest, so that's where we begin our story. Then from a certain height above the floor and bounces on the floor a number of times. Okay, well, I see multiple bounces on here. And bouncing would always happen on the same place, and that's on the floor. I see that A and C are the same position. Now, let's read the question. It says, neglecting air resistance, which point, A, B, C, or D on the graph represents the position time coordinates? Now, that sounds so complicated. So basically, they're saying where on the graph would we find the maximum height reached by the ball after the second bounce? Well, let's first identify which bounce was which. So bounce number 1 we saw was A. Bounce number 2 was option C. Well, we know that the bouncing is not going to be the maximum height. So we already know that options A and option C are completely out. So what we've got to do now is we've got to choose between B and D. Now they say the maximum height, but make sure that we read the points which are in capital letters there. It says the second bounce. So bounce once at A, bounce twice at C. The only point which is remaining is option D. Okay, once again, I think I've got my right answer. Let's just make sure that the other one can't be correct. Well, option B is the maximum height on the bounces, but it's not after the second bounce. It's after the first bounce. So there we go. We've got option D. There we go. And that is my correct answer. Okay, we're moving on pretty well. And I think we've got time for one before we take an ad break. Okay, now this I particularly like because this is an interference pattern. Let's take a look at this. So it says water waves pass through a double slit. Let's just take a look what they're talking about. Anytime they tell you about something, look at the diagram and say, okay, where are these slits? Okay, well, we've got slit number 1 over there. So let me just highlight it. This is where the waves are coming through. Remember that when you send waves through a small opening, they turn into round waves, and that's called diffraction. It's going to happen again through this next part. So now we've got 2 places where waves are becoming round. Okay. Then what happens is those waves are going to cross over each other. It says the resulting circular wave fronts produced are shown as dotted and solid lines. So it all looks very, very confusing. And what I'm actually hoping is that my producers actually got this on the screen. And you can actually see that the troughs and the crests are different lines. My crests are solid lines, while my troughs are dotted lines. So let's take a look and see what they're asking for me. So they say which one of the points, A, B, C, or D, lies on nodal lines. Okay, what did I say to you in the beginning? Choose an answer before you even look at the options. So this word nodal, okay, well, I've got to be very careful that I understand and remember what nodal actually means. If I remember from grade 10 and from grade 12, I know that nodal means that where there is destructive interference. Oh, so what I've got to do is I've got to find a place where destructive interference is going to take place. Okay, now destructive interference, I've got to remember how to get that to happen. Well, destructive interference happens when I've got a crest and a trough, so 2 opposites which meet each other. Okay, well, let's take a look. Let's take a look at our options here. Let's see where that might happen. Firstly, option A. So option A over there, let's highlight it. Option A has got 2 dotted lines. That means a trough and a trough. Now that means that option A has got 2 troughs. That will be constructive interference. 2 of the same, constructive. So definitely not option A, because that's going to be a constructive wave. Okay, what about option B? Option B, well, I can see from option B that there are 2 solid lines. That means that I've got a crest and a crest. Crest and crest, same things, constructive again. So option B is off the table. What about option C? Well, option C says to us that I've got a solid line, which is a crest, and a dotted line, which is a trough. I think we're in business. What we've got is 2 different things which are crossing each other. Okay, so a crest and a trough, when those guys cross each other, fantastic. That means that I've got destructive interference. But once again, just to make sure, let's make sure that option D is not something that we can choose. Option D over there, we don't have 2 waves. We've only got 1 crest, 1 solid line. So there cannot be interference when there aren't 2 waves. So option D is off the table. So once again, we've confirmed that option C must be the correct one. Okay, I think these guys need a little bit of a break. This is getting a little bit intense, eh?
It is, but what I'm enjoying is that they are following along, so that's great.
That's fantastic, Ty.
So on that note, Mindsetters, make sure that you keep chatting to us on the page. Make sure that you keep posting. And so you know, I have posted up the questions for you guys, so make sure you look at that. It's in the albums called Grade 12 Physics Revision. All nicely laid out for you guys, so you guys can click on and follow with us. But on that note, this is where I say, I'll see you after this ad break. And welcome back, Mindsetters. Hope you had a nice little break. You went and did whatever you had to do. You went to the bathroom, you spoke to mom, spoke to your dad, you were cooking dinner, you cut onions, whatever you had to do now needs to stop so you can pay attention. Tell them, wait, I need to pay attention right now. Phil's on TV and Ty, so we need to pay attention. But on that note, Mindsetters, make sure that you post. Let us know what you guys are thinking. And before I forget, I want to send a quick shout out to Liberty. Thank you for sponsoring the show. And on that note, I just want to remind you, Mindsetters, that guys, if you're looking for these questions, it's simple. It's written. It's in the images folder in the albums for Learn Extra. It's under Grade 12 Physics Revision. Make sure you go there and you can follow along with us. I've posted up all the questions in order for you, so it's nice and easy. You guys can download them onto your phones, onto your laptop, whatever you're using. But on that note, this is where I hand over to Phil, who's going to continue the lesson. Take it away, Phil.
Thanks so much, Ty. Okay, well, as Ty said, sometimes the writing is a little bit small. We recommend that you actually download these and follow through with us. Okay, I'm going to be reading through the questions, but sometimes a little bit, we've had to cram a whole bunch of exam questions onto one board. So please bear with us. The writing is tiny, but there's a lot of good info there. And as we said, get on the Facebook page. They're all there. Okay, so now 2.5 is where we left off. The diagram below represents 2 pulses. So let's take into account the things which we are talking about. So 2 pulses, each of amplitude A. Now that's pretty important. So that means that they are the same size. They're traveling in opposite directions along a slinky coil. Doesn't matter what they're traveling on, but basically they're coming towards each other. Now I want you to see this. These waves have got exactly the same amplitude. One is above, one is below. So if I was to label them as parts of a wave, that one would be a crest, and this one would be a trough. So the crest has got positive amplitude A. So if that's got positive A and it meets a trough, oh, wait a minute, take a look at that. A trough has got a negative amplitude of A. If you add these together, we're going to get something which is going to be 0. That's what I'm expecting. When these two come together, positive A, negative A should cancel out. We should have absolutely nothing. So remember what I said. Predict your answer first and then go looking for it. Not the other way around. Because you're going to get everything here looks right. The examiners have made sure that everything looks kind of okay. So what we're going to do is we're going to look for the option which is what we think it is. And the only option which leaves us with that is option B. So like I said, there we go. We think it's B. But what we're going to do is take all the others off the table. Well, is A correct? Well, would they add up to make double A? No. They were going in opposite directions. That would be correct for constructive crest-crest. One crest on top of the other crest, that would be constructive. We're looking for destructive. Same thing in C. If I look at option C, I see a double trough. I see 2 troughs underneath each other. That's also not correct. What about option D? Well, option D doesn't look right. What we've got is a Slinky's coil, which is actually splitting in two, which is absolutely not right. That is impossible. So our correct option for 2.5, if you're doing this with us, is option B. Okay, well, we're going to continue through these multiple choice. Let's carry on with 2.6. Okay, so now it says a set of identical light bulbs. Let's highlight that important piece of information. There we go. We've got identical light bulbs are connected as shown in the circuit diagrams. The internal resistance of the battery is negligible. That means that we can ignore it completely. Okay, which one of these circuits will the light bulbs glow the brightest? Well, here, I can't predict what they're going to show me, so I've actually got to consider each option. Now, what you've got to do is you've got to play this smart, because 3 of these have got something in common, and there's one which stands out. Now, all of them have got 3 cells, so they've all got exactly the same amount of EMF. So I know that there is the same amount of power going into these circuits. All right, so that can't be it. Now what I've got to do is I've got to realize what is different from one to the next. I can see that they are connected either in series or in parallel. Well, I've got to remember the following, is that if you connect light bulbs in series, you divide up the voltage. If you connect them in parallel, they receive exactly the same voltage. Well, that makes my choice quite easy, because option A is the only one which doesn't divide up the voltage. Each one of these light bulbs would get exactly the same and full voltage. Okay, so now we're not entirely sure about this, so we think it's option A, but let's just make sure. Let's go around the other options. We're not entirely sure at this stage. Option B, what's going to happen is you're going to divide up your voltage among 4 because they're connected in series. B is actually going to be the dimmest. Okay, well now between options C and D, what you're actually going to find is that they're actually connected in exactly the same way, except we've got a Wheatstone bridge in the case of D, and over on option C, it's just unconnected in the middle. But what you'll find is that C and D actually have the same brightness. Because what's going to happen is I've got these 2 light bulbs in series with these 2 light bulbs sharing out the voltage. That's not what you want. If you want a bright light bulb, you want as much voltage as possible. Again, in option C, we've got the series combination. That confirms that option A is the only one that it can be. And the reason for that is because we've got that lovely parallel situation happening there. Okay, so moving onwards. All right, here we go. A little bit of a definition one. 2.7. So if you're following with us, I'm hoping that you're checking answers, seeing how you're going. The unit of measurement of, okay, now let's just make sure that we're talking about the same thing. The rate of flow of charge, okay? The rate of flow of charge. Okay, well, I'm not entirely sure about this. The rate of flow of charge. Well, let's make a formula out of it. If we don't know about it, let's try and predict what it is. Rate of flow. If I'm looking for rate, I'm going to divide it by delta T. Okay? Flow of charge. Charge is represented by Q. Oh, wait a minute. If I go look at my formula sheet, I can actually recognize what's going on here. That's the way that I can calculate I. And I stands for current. So let's go see if we can't find current, and let's see if we can't find something which works with current. Okay, so the rate of flow of charge, well, that's current. A watt is a measure of power, so it can't be option A. A volt is a measure of, and careful about this, volts and current are very, very different. Volts and amperes are measures of very, very different things. They both have to do with the movement of charge. Volt is how much energy you give those coulombs of charge. So that is not it. Wait a minute, I think I've got a winner here. What we've got is an ampere, and an ampere is a measure, there we go, of current. So we think we're right. Now let's just go to option D. Option D says coulomb, okay? And coulomb is a measure of the amount of charge, not the rate of flow of charge. See what they've done there. They've purposefully put in something just to trip you guys up. It sounds kind of right. Coulomb is something to do with charge, and if you didn't learn properly, you would have taken that one. So option C is the correct one for question 2.7. Okay, now 2.8 I particularly like because this is a trick question. Okay, now it says point P. Let's identify point P. Point P is over here. Is a distance x. There we go. Distance x is drawn in for us. Okay, from the positive plate of a parallel plate capacitor. Whoa, there's a thing which I really like. Parallel plate capacitor shown in the diagram below. Well, if I remember correctly, a parallel plate capacitor has got something quite special about what goes on in between those two plates. But let's not get too far ahead of ourselves. Let's read the question first. The magnitude of the electric field. Oh, wait a minute. I know something about the electric field between parallel plates. Is E. So it's got a value of E. Now, at a distance of half x. So in other words, if I placed point P much closer, in other words, x over 2, so half of x, from the positive plate, the magnitude of the electric field will be, okay, well now everyone's going crazy here. They're going, oh goodness, all this maths and all these ratios. They've tricked you. What we didn't realize and what we didn't learn from grade 11 is that parallel plates have actually got an even field. It doesn't matter where you put P in between these, the field remains consistent all the way through. And they've put in all these scary fractions just to scare you. So I can jump straight to my correct answer, and that is C. All of these other ones talk about a different electric field strength, and that is entirely unnecessary. It stays exactly the same. They've started putting in all these numbers there just to confuse those of you that didn't listen carefully. Parallel plates have got a consistent and even electric field all the way through. Doesn't matter where you are. If you're at x, 2x, half x, doesn't matter. The field strength will be exactly the same as it was before. Okay, we're doing pretty well. We're almost all the way through these two. Let's start taking a look at some of our wave stuff. Now this stuff I particularly like. It's really, really interesting. It's physics which is relatively new. It's not 300 years old, invented by some dude with gray hair and long beard. Okay, this is really interesting stuff. Okay, so which one of the following descriptions best explains the formation of a line emission? Okay, so let's just make sure that we know what we're talking about. A line emission spectrum. Okay, well, I've got to make sure that I know what I'm talking about when I say a line emission. Emission is a process of giving off a photon when an electron relaxes. So if I've got a nucleus over there, and I've got an electron which is orbiting, and it's got several orbits around it, what happens is an excited electron over there is going to drop down to a lower energy level, and that will give off a photon of light. So I've got to make sure that I understand what's going on. This is the process of emission. Let me just repeat what I said. Okay, an electron which is an excited or upper state or heightened state of energy loses its energy by dropping down to a ground state. What happens is that extra energy gets given off as light of a particular frequency, and that's where the spectrum comes from. Okay, so now we've decided on our answer. Let's go look for it. Well, they say A, white light passes through a cold gas. Now that sounds kind of right, because that does make one of my spectra, but that makes an absorption spectrum. So they've tried to trick me there, because it sounds right, and it does make a spectrum, but it's not the one that I'm looking for. Okay, white light passes through a triangular prism? Definitely not. That's the one which gives me my full spectrum. Again, I've got to be so careful. All right, then they start talking about electrons. I'm interested. Let's read further. Electrons in the ground state move to a high energy level. That doesn't sound all that correct. Now, one thing which really bothers me about this is it's asking electrons to go up. That is a sign of absorption. So that can't be right, because we're looking for emission. Absorption is when the electrons in the ground state go up to a high energy level. So that's wrong. So I'm left with only option D. Well, let's see if it's right. Electrons in the excited state, aha, that's what I'm looking for. Excited state, there we go, move to a lower energy level. That is when emission takes place. So option D is the winner. So question 2.9, option D is definitely the correct one. Okay, I hope you guys have been following very, very nicely. We're on our last multiple choice question. and then we're going to take a short break before we come to some of the long questions. So just the last one quickly. Which one of the following electromagnetic waves has the shortest? Guys, you got to know your EM spectrum, hey? You got to make sure that you know which order these guys are in. Well, let's just do a quick revision session on which way they are. So what I'm going to be doing is I'm going to be going from long to short. And I recommend that you actually do this in your exam. And you actually find a way to remember the order of these. So from long, I'll start out from radio. And then I find my friends microwaves, ready for some popcorn. So microwaves, then I start with infrared, then visible, okay, and then UV, then X-rays, and then all the way on this side, I find gamma rays. Okay, so now I've already picked my answer, and I hope that you actually know the order of these. So from longest, it starts from radio, goes through microwaves, infrared, visible, UV, X-rays, and then gamma rays. Okay, well, let's try and find out which one we're talking about. So the shortest wavelength over here, I'm looking for an option which says to me gamma rays. And there we are. Gamma rays is right there in front of me. Option B is correct. Radio waves are the longest. Infrared rays, well, those are even longer than visible. Ultraviolet are longer than X-rays and gamma rays. Option B is the correct one. But I think what we're going to do is take a short ad break. What do you think, Ty? How's the page looking?
So too. The page is looking really good. So that's always a good sign. So mindsetters, make sure you get on the page and keep chatting, because I'm loving what's happening and I'm loving the guys who are posting and just answering questions. So everyone's following along. So guys, I'm glad that you're finding this very helpful. But do not disappear. We'll be right back after the short break. See you soon. And welcome back, mindsetters. Hope you guys have your notes and pads out and you're ready to make more notes, because we're back and I hope that you guys have done whatever you've had to do. You've gone and left whatever you had to do, and if you're cutting onions, you cut them later. Whatever you had to do, now you need to be paying attention. Get your pens and pads out and ready to make notes, because right now I'm going to hand back to Phil, who's going to continue the rest of the session. Phil, take it away.
Thanks so much. Okay, well, we're going through this a little bit slower than I'd planned, but the really nice thing is it seems that you guys are really enjoying the page and enjoying those packs that we put up there. Keep answering those questions. We've gone all the way through to question 5. Now, it's my aim to get through question 3, because I've seen a version of question 3 in every single final paper. Look for something like this, because they really, really dig this type of question. And guys, please, you'd be silly not to do this, because I've seen a version of this in every single final paper for the last 5 years. Okay. So now watch carefully. The reason that they like it so much is because there's this problem in the thinking that people have got. Okay, so now the classic question goes as such. I've got a hot air balloon is moving vertically upwards, okay, at a constant speed. Now that's pretty important as well. Okay, so it's moving upwards with a constant speed. A camera is accidentally dropped from the balloon. Okay, now this is where people really fall apart. Okay. Accidentally dropped from the balloon. And they tell me that it's from a height of 92.4, as shown in the diagram. The camera strikes the ground after 6 seconds. Ignore the effects of friction. Okay, now in my mind and in your mind, what happens when you drop something? Okay, well, I find something, and as soon as I let it go, it starts to go downwards. So what I've got to do is I've got to realize is that now this camera was not dropped from a stationary position like I dropped this. I didn't drop the camera from a stationary point. If I was moving upwards while I dropped this, now dropping just means letting go. So what happens? I just let go. But now the strange thing was that my hand and my pen were moving together. Now what happens is when those let go of each other, the pen is not going to immediately start falling. Please, just get that into your minds. Guys, think your way through this. I know that your brain wants to resist this. So if an object is moving upwards and it detaches from another object, they both continue to move upwards. However, the one that becomes detached is going to start falling under the influence of gravity eventually. It'll slow down, stop, and eventually come back down to Earth. But now I want you to think about this so carefully, because the first question asked me about that. It says, at the instant the camera is dropped, It moves upwards. They tell us it moves upwards. You cannot fight with these examiners. They know what they're talking about. It still continues to move upwards. Give a reason for this observation. So we're going to do this one quickly descriptively. The reason that the camera still moves upwards is because of Newton's first law. What happens is that an object will continue in a state of motion. It had inertia. It will continue to move. Eventually what happens is gravity will slow it down, it'll stop, it'll turn around and start coming back down. Okay, but please, the camera has got inertia. So it's not just going to suddenly stop dead and start falling. It was moving upwards with the balloon. So that's what you can say, is that the camera was moving with the balloon. It was moving upwards initially. It's not just going to suddenly stop. That's impossible. Okay, now 3.2 is where I place my interest. Now it says to calculate the speed, okay? VI. Now the reason that they've chosen the word speed is because you don't really need a direction, but they have called it V for velocity. So what they're saying when they say speed is you don't have to give a direction, at which the balloon is rising when the camera is dropped. Okay, well what we've got to figure out is if I've got my little camera over there, and there it is. So there's my little camera. My camera continued to move upwards, and eventually it's going to fall all the way back down my 92.4 meters. Okay, I know a whole bunch of information about that, but what I've done is I've done the first step in doing my equations of motion. DDTE, diagram, direction, table, equation. So what I'm going to do is diagram first. So I've drawn my diagram here. I've drawn what I think is going to happen. I always draw pictures. I cannot do physics without pictures. So diagram first. Then I'm going to choose a positive direction. So what I'm going to do is I'm going to say that up is positive because I know that my answer is an upwards one. I knew that the camera was moving upwards. So I want my answer to come out nice and positive. So I've chosen up as positive. There is no such thing that the down or the up is always positive. Don't do that to yourself. Understand that you choose the positive direction. Stick with it. So there it is. Diagram, direction. So there's my first two Ds, diagram and direction. Now what I'm going to do is I'm going to do a table of what I've got. Okay? And VV, so V initial, V final, TAY. So VV T. There we go. So my initial velocity, which I'm looking for, let's make a shopping list. Let's see what I got. Okay, well, my V initial, that's the question mark. That's the one that I'm after. My final velocity, don't know, don't actually care because they didn't ask me. So what I can do is temporarily I can cross VF off my list. I don't know how fast it hit the ground. They didn't ask me how fast it hit the ground, so I can ignore it for now. However, they did tell me that the time was 6 seconds. Acceleration, now this one's quite tricky. Do I know the acceleration? Well, I know that this object is under the influence of gravity the minute I let it go. So that means 9,8 meters per second. But what I've done is I've made a mistake. And this is a mistake that you guys often make. I've forgotten about my directions. Acceleration is due to gravity, and gravity pulls downwards. Even though the object is not moving downwards, you can have an acceleration in that direction. Now let me just repeat that. You can have an acceleration in a direction that you're not moving in. How can that be? One of the ways that you can think about this is if acceleration is in a different direction to your motion, that means that you're slowing down. Okay, last piece of the puzzle, my displacement is negative 92.4 meters. Now, how can I say that it's negative 92.4? Well, that's also downwards. The camera is going to land further down than it was up. I now have my information. What I've now got to do is my last step, is my equation. If I've done these 3 steps, I don't have any marks yet. But these 3 steps ensure that I choose the right equation and that I use it correctly as well. So what I'm going to do is I'm not going to go around and say, okay, well, I need an equation which has got VI and delta T and A and delta Y. You're going to waste a lot of time. There is an easier way to do this. What you've got to do is find the equation without VF. So that's much, much easier. You can just look through an equation. Oh, there's no VF. Okay. Now I've got a way to go forward. So let's do 3.2 together. Okay, so now we may not get a time to go through all of this, but 3.2 is something that I really want to stop and focus on. Okay, so the only equation which doesn't have VF in it is the one which starts out with my change in displacement is equal to VI delta T, okay, plus a half A delta T squared. Okay, so now what I'm going to do is I'm going to substitute in what I've got and see what comes out. So now I know that my displacement is equal to negative 92.4. So there it is. Don't forget the signs, because the signs are more often than not the problem. So VI and then delta T was 6 seconds plus a half. Negative 9.8 is my acceleration. There it is, delta T squared. Don't forget my delta. There we go. All right, we've forgotten to fill in my delta T. Let's just make sure that we get that right before you guys get on the page and shout at us. There we go. So 6 squared. There it is. So now what I'm going to do is I'm going to start to simplify, start to manipulate, and then I can find my VI. Okay, so let's get VI on its own. I've already got it over there. So what I'm going to do is simplify the rest of this. So I've got negative 92.4. I'm going to bring across all of this. So I'm going to have a negative half. So if I bring it right across, I'm going to have negative a half of 9.8. This is all getting a little bit messy, and we're going to tidy it up using a calculator in a moment. Squared is equal to VI multiplied by 6. Oh, that's starting to hurt my head a little bit, and we've gotten out a negative. Let's just double check that you don't drop any signs. Let's tidy it up. Let's use our calculator. Okay, so what I'm going to do is I'm going to start to enter in the left-hand side. Let's enter it in. So negative 92.4 minus, and let's put in my half. So 1 fraction 2. There we go. Putting it to the next. Don't forget negative 9.8. And don't forget that we've got 6 squared in the next bracket, another thing that everyone forgets. And that's going to get an answer which is not quite there yet. I've got 84. That's not my final answer. So I've got 84 is equal to VI multiplied by 6. What I still need to do is I still need to simplify that by dividing both sides by 6. And that'll get me an answer of 14. So I get a V initial of 14 meters per second. Now, at the end of every physics calculation, I must check to see if what I found actually matches what I expected. Well, I know, for instance, that the initial velocity of this balloon with the camera was upwards. Well, that means that the V initial must have been a positive number. Was it? Absolutely. It definitely was a positive number. Okay, I think we've got time for a very, very short question. What do you think, Ty?
I think maybe we should just squeeze it in as quickly as possible.
Okay, all right, so 3.3. Let's do some speed science. Okay, so draw a sketch graph of velocity versus time for the entire motion of the camera. Now, they want the initial velocity and the time at which it reaches the ground. Okay, well, they want a VT graph. Okay, now what I'm going to do is I'm going to keep up as positive. So here it is. There's my velocity, and there is my time. Okay, so I don't need a ruler, luckily for me. So my velocity, which is measured in meters per second, and my time, which is measured in seconds, there are my axes. I need to label them, and I need to put in my units. Okay, now I've got to be very careful about how I do this. I knew that I started out at 14 meters per second. There it is, 14 meters per second. Eventually, what's going to happen is this camera is going to slow down to a stop at 6 seconds. But now, it's going to stop way, way, way before then. I've got to not fall into the trap of thinking that it stops only on the ground. There's 2 places. It stops at its maximum height. Eventually, it reaches the ground 6 seconds later. So what do I put on my graph? Well, I've got to be smart about this. I know that eventually it's going to reach a point near the ground traveling at much faster than 14 meters per second, but I can't actually say without calculating. All that I know is that the velocity is going to steadily decrease through 0. That's when it changes direction and carries on downwards. So what I need to say about that point is that that point itself is 6 seconds. So 6 seconds is once it's gone all the way up. This is a place where it turned around. I need to understand this. So this is where it turned around. And then what happened is that it fell all the way down. Okay? So this is the fall. This is the downward part. So then it went up, it stopped, it turned around, and then fell all that way down, all that 92.4 meters, all that way down. So now, left with about a minute. Unfortunately, what I'm going to be doing is I'm actually going to be carrying on this particular lesson. We're going to keep on posting up those questions up to the page. Now, what I want you guys to do, start working through these, please, as many past papers as you can. By the time you walk into your final, you're going to feel like it's home again, because these questions all kind of start to look the same. So now, in this type of question, they like to give you these balloons where something detaches. I've got to remember that it's going to carry on moving upwards, stop, and then turn around. They love, love, love these questions. Expect one in your final. There is always a graph and an equation of motion question to start out all of these. There is always multiple choice. You know what to expect. These question papers are free with memos online on our website, on the Learn Extra website, or you can take a look on Sutong's website, the government's website. But what we're going to be doing is making them into bite-sized chunks for you guys. But that's it from me tonight. We're going to carry on with us for next week.
All right. So mindsetters, matric specifically, I hope you guys were ready. Well, I hope you guys made some notes. You guys have prepped, and I'm hoping that this pack helps you guys. Just make sure that you keep going through it. And guys, I just want to also make a quick note. There will be live sessions on Saturdays. Physical science is going to start from 10:30 until 12:30. But this is where I'm going to say, see you and cheers. Liberty. Bye.